Welcome back. We're going to be looking at control flow instructions in C and C++. For the C part, we're going to go fairly quick through that because it's a review, and C++ takes the control primitive of C and we use them as is. So that's quite easy to understand. We'll spend more time looking at the C++ side of the picture. But first, maybe a little cartoon to help you appreciate a fundamental message about what structured programming means. And if you think that doing something that's not structured is harmless, beware, you could have a velociraptor running right at you and ripping you in pieces for doing so. So be very careful. It's important to stay reasonable when writing code. So, overview. We'll review C real quick, and then we'll look at C++, and in particular, we'll look at exceptions, range loops, and eventually we'll look at intervals. So, the first thing, branching. In C, well, that's quite easy. You essentially have two instructions, if condition expression, or if your condition, which is an expression, then a block, and an else block, so an if then else. These are your only alternative, and they're quite straightforward to understand. What you get is basically that if the condition is true, you do the then part. If it's false, you do the else part. And if there is no else part, you're completely good. Now, your block normally should be a single instruction. If it's more than one instruction, you need to use curly braces around this. So this is not all that difficult to do. So that's all there is to say to if. I'm not going to agonize over that. The switch instruction, a little richer, right? What we have is switch based on an expression that evaluates the specific value, and then we have a case analysis. If the value happens to be labeled 0, so that can be what? Well, it depends on the type of the expression. If the expression is a character, label 0 could be a character. If expression is an integer, then label 0 should be an integer. We just need to be consistent. But it only works with scalars, and in particular discrete ones, not even floating points. So switch is perfect for discrete values, like character, short, integer, long. That's perfectly appropriate. So what you have is a case, label, and then a block. Then you repeat case, another label, another block, case, another label, another block. And there is an optional default that says if none of the case match, this is the block you should be doing. And it's in red bracket here to show that this is an optional construction. Now, to illustrate what it does, I've shown this control flow chart on the side. And this is what you have in mind, is that you evaluate the expression, and then depending on which label it matches, you pick the corresponding block, you do it, and then you go and do whatever the next thing happens to be. The next block is, of course, the instruction that comes at this point, right? After the switch instruction. So that's what you're thinking. But you're going to be extremely careful, because if you write your code like that, this is not exactly what you get. Why is that? So this is no good. That's what you want. But that's not what you get when you write this. What you should do is remember that you have, in C and C++, you have an instruction break that really breaks the control flow and says, after this point, we don't go on in sequence, we go to the next instruction. Which means if you're inside the switch and you want to do, if the case label 0 applies, you want to do that block and then nothing else, you have to have a break statement here to go to this place next. Otherwise, you go on in sequence, and from this block, you would be executing this one, and that one, that one. Which means what you're really doing is that when you terminate a block, you enter automatically the next block in the sequence based on where your keys are. The only promise is that the compiler is not going to rearrange the blocks. They're not going to change in order. So the order in which they are listed in your switch statement is the order in which they would be done. You can use that to your advantage sometimes, but 99% of the time what you want to do is, if label I applies, you do block I, then you break out and you go and do the instruction that's after your switch statement. You want the other picture. To get it, that's where you use the break instruction. That's the only thing that's really worth remembering. Break serves that purpose. You break out of the switch, out of the branching, to go to the next instruction after the switch and not do the other remaining cases sequentially after you, not do them. Now, the while loop exactly as in C. You notice that each time I'm saying that's the same as in C, that's the same as in C. What you have is while, a condition, which is an expression, and then you have a single statement. Of course, you can have multiple statements, in which case you use the curly brace to define a block. The control flow graph is this one, and there's nothing shocking. When you come into the instruction from the top, you have a decision, that's what you see there, that tells you whether you should carry on or break out. If you should carry on, though that's the true branch, you do the block, the body, and then you wrap around and you retest the decision. If the decision tells you enough, let's break out, then you follow the other path and you go to the instruction that's after your while. Completely straightforward, same as in C, same as in Java, right? So remember, C is the ancestor here, and all the control flow is quite similar to what you are accustomed to in C and in Java, if this is where you're coming from. Now the next one is not any more difficult, is the do-while. What is, if you recall, what's the difference between while and do-while? Well, the while first tests the condition. When you're here, you test the condition, then you enter into the loop, which means you might do the loop 0 times. If the condition is false when you hit the while, you won't even enter the loop. The do-while, however, does the loop at least once, because it says, let's do this as long as this condition is true. So you will do the body at least once, and then you test after. And if the condition is true, then you keep on going. While the condition is true, you iterate. When the condition is false, you break out of this statement. So that's our control flow. We come in, we do the block. After the block, we make the decision, we evaluate the expression. If it's true, we wrap around and we redo the block again. If it's false, we escape. Okay? So that's fairly straightforward. Again, completely identical to what you're accustomed to. Counting loop, that's your for. You're completely used to that. Again, 2 variations, whether your body is a single statement or a block. But fundamentally, the for says, let's have a declaration, then you have a semicolon, then an expression. Expression 1 here is the condition to stay into the loop. And then we have a second expression, expression 2, that tells us how we go to the next iteration. And then finally, the single statement, or here, the block, so that should say block. The block can be a sequence of instruction, and it gets done as long as the condition is true. So the control flow tells us, we come in, we do the declaration that creates typically a local variable. So you would say like for int k equals 0, which is the 99 version of the C standard. You put the declaration directly in the for block. You would say for int k equals 0, semicolon, k less than some condition. So you evaluate the condition expression 1. If the condition is true, you do the block. Then you do expression 2 to go to the next iteration. Typically, what is expression 2? Something like k++. You're going to the next iteration, and after that, you wrap around and you repeat the evaluation of the condition. Once the condition becomes false, you exit. Note that in this scenario, just like while loop, it's very possible that you never execute the body of a for loop, right? You don't have any guarantee that it will run at least once. Good, so that's counting loop. We already mentioned break, right? Break is used mostly with switch. That's where you will use it 99% of the time. But you can use it also inside loops, inside while loop, do while loop, or for loop. And what it means is, if you're inside the loop and you execute the break statement, you don't finish the remaining iteration of the loop. Think that if you take your loop and you unroll it, having multiple instructions, the break says, we're jumping over all future iteration and going directly to the next instruction, whatever that may be. We don't want to finish the loop. That's why you break. Personally, I think that it makes the code a little harder to read. Very often you can avoid the break by simply folding into the condition of your loop a predicate that tells you when you should break. If you are inside the body of the loop saying, if this condition is true, then break, then you could take that condition and put it in the condition of your loop to say that you go on as long as the condition is not true. The moment the condition becomes true, you don't do that iteration and you come out. So I find this to be a little bit easier to read So I would suggest that you do that, but it's absolutely not necessary. Once you're really comfortable with your break, you can do it. Remember that if you have nested loops, the break only break out of the innermost loop. If you have outer loops, they're not affected. You will go to the next iteration of those. So you break only out of one thing. And of course, if you have a loop with a switch inside, and then a break inside the switch, the break actually breaks out of the switch. It doesn't break out of the loop. So the break always break out of the innermost statement that supports it. That's all there is to it. Now, continue is a partner in crime in a sense. What continue is all about is simply saying, oh, I don't want to finish this iteration of the loop. I want to go to the next iteration. So you're skipping the end of your iteration. Maybe a little bit of a picture is in effect for this. So let's say that you have while some condition, and then you have statement 0, statement 1, and then at this point you have if some predicate P is true, you continue. And then you have statement 2, and statement 3. And we close the loop. What's happening when you have that? Well, think of the control flow in this case. What you're going to see is that the body, I'm going to break down into several parts. I have the part where I do S0 followed by S1. Then here I'm coming to a decision where I'm using the predicate P to decide what to do. And if P happens to be true, here, true, I'm going to continue, which means I don't want to do S2 and S3. If it happens to be false, I go into a block that does S2 followed by S3. Once this is done, S2 and S3, what do? Well, I go back to the top where I'm going to do that other condition, which is my predicate here. So I will come, and let me draw that a little higher. I will come back into this place. I will evaluate C. If C is true, then clearly we carry on. So true follows this path. If it's false, that's quite easy. We leave. That's, let's call it NS, the next statement. So I go to NS. And what about this path that's not finished? Well, that's the path where I say continue. So the continue here basically sends me there. I skip the rest of my iteration, but I go back up. I decide whether I should iterate again and potentially do another iteration. So it skips the end of the current iteration. That's the whole point of the continue in this case. And that's all there is to it, really. It's a quite straightforward construction to work with. Good, so now let's go take a look at the next instruction. And that one is a dangerous one. It's called goto. And in OB1's own word, this is not the control flow instruction you're looking for, so carry on. There is nothing to see here. Don't use goto. Don't. Just don't. Bad things will happen. Don't use it. It's in the language, but you shouldn't use it. Okay, carry on. I'll see you next time, and we'll look at exceptions, which is a very important topic for C++. So we'll take a close look at that. If you've seen it in Java, it's quite similar, so it shouldn't be too much of a trouble. See you next time.